So to write equations, we're going to write the equation for each one. Linear is the easiest one. Remember, to write linear, you need the slope and the y-intercept. That's all you need, okay? So we're going to write y equals mx plus b. And again, slope and y-intercept is all you need. Your y-intercept right here is 0. And then remember, your slope, you do rise over run. So we rise 1 and we ran 3. So rise 1, run 3. And the only other thing you need to remember is this is a positive graph, so it's going to be a positive 1/3. So your equation is a positive 1/3 slope. And then plus 0 for your y-intercept, but you don't need that. You just need the 1/3 x. Okay. So it's a real quick equation to write. I'm going to do like I did yesterday, and I'll go through all the linears. So I'm going to go down this column, and then I'm going to go to the absolute value because you pretty much write them the same way. And then we'll go to quadratic and exponential. Okay. So then your next one, we again, our y-intercept is at 0. To find our slope, we connect our points and we do rise over run. 1, 2, 3, 4, rise 4. We run 1. It doesn't matter what side you put that triangle on. Okay, you could put it on the other side of the line. So rise 4, run 1, but this graph is going down. So it should be a negative. So remember, y equals mx plus b. Y equals negative 4 over 1 is negative 4x. And then we can put the plus 0, but again, you don't have to have it. Sorry, y'all. You can just have negative 4x. And then the last one, remember we talked about these very briefly at the end of our notes, right before we did domain and range. And we have this equation or this graph. Remember, it's whatever axis it goes through. So this one cuts through the y-axis. So our equation is y equals. And then where does it cut through at? Negative 3. If it were the other way, so say I made one that looked like this, just to give you an example in case you have it on your quiz today, okay? This cuts through the x-axis and it cuts through at 1, 2, 3, 4, 5. I just want to give you an example of both, okay? You may want to write that down. All right. Going to go to linear absolute value. Again, I don't really call it linear absolute value. I just call it absolute value. They just use linear to try to relate it. So remember, our equation looks exactly the same, except for its absolute value of x plus b. For now, since we're starting at 0, 0, this will change at the end of the other notes because we're moving our vertex. We're moving our vertex from 0, 0. So for right now, this is going to be b. B is going to equal 0. Our slope, connect 2 points, just like always, and do rise over run. We went 1, 2, 3, 4, rise 4. And we ran 2. And since this V is pointing up, we know it's going to be positive, okay? If it were pointing down, we'd use negative. So rise 4, run 2 is actually 2. Is everybody okay with that? So your slope is 2, and then just the absolute value of x. The difference in the next one is it actually points down. All we're looking for is the slope right now. Eventually we'll change it because we're going to move that. We won't change the slope. The slope will stay the same. But we'll change what the ending of the equation looks like based on where our vertex is, okay? So right now we have 0, 0. So we'll have that plus 0 on the end. We're going to do our rise and our run. Our rise is 2. Our run is 4. But this one's pointing down. So rise 2, run 4. Since it's pointing down, it's going to be a negative. That reduces to negative 1/2. So our equation is -1/2 absolute value of x. I don't have to put the 0. Okay. So anytime it's a parent graph, the equations are fairly easy. All right. On your next one, our slope is rise 2, run 2, rise over run. What else do I know about the slope? It's negative because it points down. So -2/2 is -1. So our equation is going to be -1 absolute value of x. And then you can put the +0 or not. I don't mind. But how you'll see it on a final exam, if it's multiple choice, would just be negative absolute value of x. The 1 wouldn't even be there either. Okay. All right. So then quadratic. Here's your quadratic equation. Okay. So this is actually vertex form of the equation. You guys have seen it as ax squared plus bx plus c. Okay. This is vertex form. We'll eventually learn how to put it in vertex form. But for now, the easiest way to write this equation is have it in vertex form. And we'll use this vertex form on all 4 types of equations. Okay. So here's your first one. We have 0, 0 because that is our vertex. Once we change our vertex, those 2 numbers will change. So this 0, 0 comes from our vertex. To figure out what our A is, that's our goal, is to figure out what A is. So that's like our slope. We're going to plug in another point. They give us another point. That point is 3, 2. That's going to become your X and your Y in the equation, because remember your coordinates are X, Y. Again, the 0, 0 comes from the vertex. We're going to see this change in our next set of notes. So what is your Y coordinate? It's right here. What's our Y coordinate that we have? 2. We don't have our A. What's our X coordinate? 3. Plus 0 squared plus 0. This plus 0 doesn't really matter right now. It's not doing anything. Inside we have 3 plus 0. And I'm going to go ahead and write this one down, but the next ones I probably won't, which will give you 3 squared. 3 squared is 9. How do we get A by itself? Just a regular solving. How do we get A by itself? Zoomers, you can answer too.
You divide.
Divide by 9. And we get that A equals 2/9. And that's okay. That's perfect. So then our equation is Y equals, we're going to plug in that A, 2/9. And we just have X squared. Why do we just have X squared? Because we have a vertex at 0, 0, and those zeros won't matter. Okay. If you look at your next one, your vertex is at 0, 0. So you're going to start the same way. X plus 0 squared plus 0. You're going to find your other point, and they labeled it for us. And where is that coordinate at? Anybody? What's that coordinate right there? -4, -5. Perfect. -4. I'm trying to make sure you guys can see it. -5. And that's our X and our Y that we're going to plug in. -4, -5. So what's our Y coordinate? -5. We're looking for A. Our X is -4. And then you have the rest of the equation. Remember, this plus 0 on the end is not going to change anything. -4 plus 0 is -4. -4 squared, remember negative times a negative makes a positive. So anytime you square, it's always positive. 4 times 4 is 16, and we're multiplying that by A. Guys, please make sure you're on time. How do we solve for A? divide 16. And you can leave it just like that. A equals -5 over 16 because it will not reduce. So then our equation is y equals -5 over 16 x squared, because we don't have any vertex other than 0, 0, because it's at the origin. Once we move away from the origin, there's probably going to be a number with x, and there's going to be a number on the end. So those 2 zeros will be replaced. All right, last one of these. We have our origin at 0, 0. Again, that's where those 2 zeros come from. Then we have another coordinate that's going to fill in our x and our y. So it's at 2, 4. Our y coordinate is 4. We're looking for A. Our x coordinate is 2. Again, this 0 on the end doesn't matter. It's not going to change anything. 2 plus 0 is 2. Squared is 4. Multiplied by A is 4A. So I just didn't do all the work in there. Again, 2 plus 0 is 2. Squared is 4. Divide by 4, and A equals 1. So our equation is 1x squared, or just x squared. All right. Exponential becomes the hardest one when you move it around. Okay, right now it's going to be super easy, but when you start moving it, it's going to be kind of hard. So exponential, remember, is y equals a times b to the x. And for our parent graphs, our a is always 1. Remember, our a is our y-intercept. Okay, y-intercept. So we know that a is going to be 1 because that's our y-intercept on our parent graph. So again, this is a. We're going to do the same thing and get our other coordinate. So our other coordinate up here is 3, 8. So our y coordinate is 8. We have a b, and our x is 3. This one does nothing. You should know this from here, but if you don't, it's okay. All right, so it's okay. So I need to figure out what to the third power gives me 8. So what to the third power gives me 8. If you can't do that, remember, if this were a square, we'd take the square root, but it's a cube, so we're going to take the cube root. So that means that little 3 right there. Now, what's good, again, is that you get your calculator all the time. So I'm going to show you where that's at on your calculator. And if you forget, remember, I'm recording this, so you can go back and check it. You go to math, and you go down to this cube root. So number 4. Now, if it's bigger than that, because I think we're going to get, not on this one, we're not. If you get bigger than that, then you type in the number and you go to number 5. So like if it were 4th root, you would type in 4 and then go to number 5, and it'll throw that little thing up there, okay? So cube root and square root are easy on your calculator. Anything else, you have to type in the number and then go to number 5, okay? So cube root of 8, and we get that b is 2. So our equation is y equals 2 to the x. We don't need the 1 in front. If you put it in there, that's perfectly fine as well. Okay, so if we look at the next one, we have the same thing, y equals ab to the x. Our y-intercept is at 1, so our a is 1. We don't know b, and then they gave us our x and y coordinate. So our y is 27, our x is 3. So what we're looking for is what to the third power gives us 27. So we'll take that cube root again, math 4 of 27, and we get 3. So our equation is y equals 3 to the x. Exponentials are the only ones that you can't do on your calculator, okay? The rest of them, before the test, I will show you how to do it on your calculator. All right, do it by hand first. Guys, I don't want screenshots of your calculator graphing. I want to know that you know how to graph it by hand. So today, if you have to graph, most of you did it. A couple of you turned in screenshots of calculators yesterday. I don't want screenshots of calculators. Got it? Guys, you have to be on time. 8:40 every day, 8:40. The next one, y equals ab to the x. We have our y-intercept at 1 again. That will change eventually. We don't know what b is. And then we have our x and our y. Our x is 2. Our y is 100. So again, the 1 doesn't matter. You shouldn't need your calculator for this. Like I said, what squared gives you 100? If you don't know, remember to get rid of the square, we take the square root. So we square root 100. Then we get that b is 10. So our equation is y equals 10 to the x. And that finishes up your notes from yesterday. Again, you didn't have any homework on that or anything, but those will be on your test, okay? Maybe not these easy ones, but the next ones probably will be. All right, so to keep it kind of short, I'm going to go through this and explain to you really quickly what's going to happen, okay? So I'm going to write these up here, and then this part, it looks like a lot, but it goes real fast, okay? It goes really fast. So f of x plus a, we're adding a to the end. Adding a to the end moves the function up. Subtracting a to the end moves the function down. And we're going to look at those, and I'm going to show you. If we add to x, this is the one that's kind of tricky sometimes. If we add to x, it's going to be inside a parentheses. So I showed you how it was like x plus 0 squared plus 0 in parentheses. When you pull that number outside of parentheses, so anytime you put a number in or you pull a number out of parentheses, you always change the sign. So this is actually going to end up being a negative a. So if it's on the x, x moves left to right. If it's negative, it's to the left. So you got to think opposite when you're dealing with x, okay? And then x minus a, when you pull that out, I'm just going to show you on this one. When you pull it out, it becomes a positive a. Dealing with the x-axis is either going left or right. Since it's a positive a, it's going to the right. All right. So the very first ones that you see are just parent functions. So we're just going to write parent functions. How do we know that they're parent functions? Let me slide this up so you guys can see it. How do we know they're parent functions? They go through 0, 0, okay? The exponentials go through 1. Now, if you look, all the graphs are the same. What it wanted you to do was just move it however. So this one, f of x plus 3, what happens? So I want to show you with quadratic. When I put in, you do not have to do this. I'm just going to show you. You can do it without doing any kind of graphing, okay? So I'm going to show you the tricks in a minute, but I want you to visually see it. And then I put in 3x squared plus 3. Up here, it said if I add to the end, then I'm going to move this function up, okay? So we're going to see what it looks like. There's your parent graph at 0, 0. I added 3. So what happened to the red graph? It moved up 3. Got it? So anytime we see this, regardless of what graph we have, whether we have linear, quadratic, linear absolute value, or we have exponential, we're adding 3 to the end. Oh, sorry. It moves the function up 3. Okay, that's literally it. There's no work to do. What it wanted you to do is graph every single function. I'm not making y'all do that, okay? I'm not doing that. So I'm going to keep working with the quadratic. I meant to leave that one in there. And I'm going to look at this one. What happens to this one? We're going to subtract 4 on the end. So when I graph it, here's your original at 0, 0. That's the one that's actually graphed on the paper. What happened when I subtracted 4 to the end? What did the function do? Went down what? 4. Went down 4. Why did it go down 4? Because it says minus 4. Okay. So this one, subtract 4 to the end. Means it goes down 4. All right, we're going to flip our paper. Again, I'm going to keep looking at that quadratic one, but I'm going to show you how it's manipulated. Okay, so this one adds 4 inside of parentheses. So it'll be 3 parentheses, add 4, and then squared. Okay, let's see how it changes. Which direction did it go in? To the left, and how far? What's your number? 4. Does everybody see that? So remember what I told you, we put this 4 inside. So we have to take it out to make it a negative 4. And X deals with left or right. And since it's negative, we're going to the left. So add 4 to X means we actually move left 4. On the next one, we're going to subtract 3. Watch what happens. Here's your regular parent function. When we subtract 3, it actually moves to the right. So remember, when we pull it outside, it becomes a positive 3. And then X deals with left or right. If it's a positive, it's going to the right. So if we subtract 3 to X, we actually move right 3. So then the next two on the bottom of this paper, they combine them. So there's 2 things going on. They're either moving left, right, or they're moving up and down. Okay, so they're doing one of each. And you have to tell me, they're all exactly the same. It's just showing you the function, what it looks like. Okay. So if we look at this one, and again, I'm just going to look at this quadratic one right here. We have a negative 2 on the end. So what does that mean? On the end, it's either up or down. And so this one's negative, so it's going to be down. And then how much does it go down? What's the number? 2. All right, so inside, remember we take it out and we change the sign, so it's actually going to be a negative 3. Remember that one deals with left or right. Since it's negative, which way is it going to go? Left. Same thing on the other ones. Okay. Look at the last one. We have a +2 on the end, means up or down. Since it's plus, what's it going to do? Up. And it's going to go up that many, so 2. Inside parentheses is telling me left or right. And remember, you're going to pull it out and make it opposite sign. So this is going to be a positive 4. Since it's positive, which way does it go? Left or right? Right. And it goes right 4 because that's the number that's with it. All right, everybody good? So far, so good? All right, so now we're going to write equations again. I'm going to show you how to do these on your calculator more than I am how to show you I just like it better on your calculator. The problem is when you get to quadratic, I really want it in vertex form. You're probably not going to get it in vertex form, okay? So on your test, if you give it to me either way, it's perfectly fine. But for right now, I would really, really like it in vertex form. So I'm going to show you by hand and then I'll show you on the calculator. All right, so this one, the two things we need are our y-intercept and our slope. This one, it's harder because you have to find the slope, okay? So we have to find the slope. Remember your slope formula from Math 1? We're going to do rise over run. You can look at it. Your rise is going to be your y's. Your run is going to be your x's. Or you can do, remember your formula, y minus y over x minus x. If you can see it, do it. If you can't, don't. If you have graph paper, plot it on your graph paper instead, because this is really crappy that they show you like this. So if I did 1, 2, and -3, -2, we can go ahead, because it's on pretty paper, find our rise and run. Guys, you can do this and that's fine instead of having to do the formula. If you want to do the formula, do the formula. So we did our rise of 4 and a run of 4. So rise over run is 4 over 4. This one is positive or just 1. So our slope is 1. All right. To figure out what our y-intercept is, we can see it on our graph. So we could use that, but if it were a decimal, I'm going to show you how you actually get that. We have our formula y equals mx plus b. You pick either coordinate. I'm going to pick 1, 2 because it's positive. That's going to be your x and y. Your y is 2. We found our slope was 1. Our x is 1. And we're looking for b. We're going to solve it. 1 times 1 is 1. And then we're going to subtract 1, and we get b is 1. Now realize that I can see that on my graph right here. So it may be easier for you to just go ahead and graph it, okay? It may just be easier. I hate that they didn't put it, these are not my notes, I stole them from somebody, so I hate that they didn't put it for real, okay? But if you need to, make a good one. So then your equation is y equals 1x plus 1. You don't have to have the first one, it can just be x plus 1, but I wanted to show you where it comes from. So we got our slope was 1 and our y-intercept was 1. I'll show you the next one and I'll graph it so it's really pretty for you. -2, 5, and 3, -2. It looks like our y-intercept is at 2. Let's hope it is, that I can draw straight. I don't know if it is or not. So we're going to actually find it. But we can do our rise and run. I count boxes, so I put the little dots in them. My rise is 7, my run is 5. But what do I know about this line? It's negative. So we have a -7/5. Right. So to start our equation, we got y equals -7/5 x plus b. Choose a coordinate. It doesn't matter which one. I'm going to choose this one up here. If you did the other one, it's going to come out the same way. It doesn't matter. So my y was a +5. My x was -2. And then plus b. Again, I think my graph is a little off, so don't stress out about that. We're going to solve it. -7/5 times -2 is 2.8. And then I need to subtract 2.8. And I get 2.2 or 11 over 5. You can leave it as 2.2, I don't care. Decimals and fractions don't bother me. So my equation is my slope, -7/5 x plus 11/5. So that one was really crappy, sorry. And then the last one you don't have to do any work on. What axis does it go through? Which one does it go through? The y-axis at what? 2. Perfect. So I don't have to do any work on there at all. All right. I'm going to go to the absolute values. Absolute values. Remember, I told you we're going to have m x plus 0 plus 0. Remember, I told you those plus zeros are going to come in. That 0, 0 is your vertex, and that's going to happen on your quadratic as well. Okay? It's going to happen on your quadratic as well. Our vertex is 4, 2. Our vertex is 4, 2. So remember, when I put my x inside, I'm going to change it. So it's going to be a -4. Change x. But keep y on the vertex. And then our y is 2. So it'll be a +2 on the end. Okay, so that's the very beginning. We were having 0, 0. Now we have a vertex. Change x, keep y. And that's going to happen on quadratic as well. You use the other coordinate, just like we did in the beginning, as your x, y. So my y is 5. I'm looking for m. My x is 5 minus 4, absolute value, plus 2. We're going to clean our absolute value up. 5 minus 4 is 1. Remember, absolute value is always positive, so the absolute value of 1 is 1. So we'll have 1m or just m. And don't forget your plus 2 on the end. To solve for m, we're going to subtract 2, and we get 3 equals m. We're going to do a few of these, so don't stress out if you're not quite getting it. Okay? Also, if you have trouble doing your homework, ask. Just ask. So here's your new equation. Y equals, our m was 3. We had absolute value. We're going to use all of this. We're just going to copy it down. X minus 4 plus 2. Which one is my vertex on the next one? -3, 2. Remember. Change x. Keep y. So we're going to start at y equals, we're looking for the m. X, our vertex is -3. So we're going to change that x to +3. But we're going to keep our y of +2. That's your first start. Nose is really itchy. Sorry, y'all. All right. Remember, your other coordinate is your x, y. So my y is -1. I don't know my m. That's what I'm looking for. X is -5. And then finish out my equation. Clean up your absolute value. -5 plus 3 is -2. Absolute value is always positive, so the absolute value of -2 is +2. And then we still have the +2 on the m. Subtract your 2 from both sides so we can solve for m. We get -3 equals 2m. Divide by 2. We get m equals -3/2, which we should get because it's upside down. And then our equation is y equals -3/2. And then we're going to finish up with the end of this equation. Absolute value of x plus 3 plus 2. All right, one more of these. Your vertex is 0, 4, so there's your x and your y. It doesn't matter to change the sign because it's 0. So change x, keep y, so +4. Our xy is over here. So our y coordinate is -1. We're looking for m. Our x is -3. And then finish out the rest of the equation. Clean up your absolute value. -3 plus 0 is -3. The absolute value of -3 is +3. Subtract your 4 so we can solve for m. We get -5 equals 3m. Divide by 3 and we get m equals -5/3. So our final equation is y equals -5/3, and the rest of the equation comes from right here in the very beginning. X plus 0 plus 4. But remember, if it's multiple choice, you will not see that 0. It'll just be absolute value of x plus 4. I think there's something in my mask making my nose itch. I don't know what it is. I'm sorry, y'all. All right. Quadratic. Quadratic. It is the same exact thing that we just did. It's the same exact thing that we just did, except for instead of absolute value, we're going to square it. That's it. All right. So our quadratic is going to be a x plus whatever our vertex is, plus or minus whatever our end is. So it's going to look like that. So our vertex is at 4, -3. Same thing, change your x. So inside it's going to be -4 squared. Keep y, so -3. Okay, same exact thing we just did. It's the same. All right, our x and our y are the 6 and -1. So our y is -1. We're looking for a. Our x is 6 minus 4 squared minus 3. Just like we cleaned up the absolute value, we're going to clean up the square. 6 minus 4 is 2. Squared is 4. So we have 4a minus 3. You're going to solve for a, so add 3. We get 2 equals 4a. Divide by 4, and we get a equals 1/2. Our equation is the same as the one at the top, except for we got to put our a in. So y equals 1/2 x minus 4 squared minus 3. I'm going to do one more of these since it's repetitive, okay? It's the same thing. So I'm going to do one more so I'm not wasting too much of your time. We're going to start here, y equals a parenthesis x. My vertex is -1, 3. Change x, so +1 squared, and then keep y +3. So this is the equation you should have at the end, but with the a added on there, okay? With the a filled in. The other coordinate is our x, y. So x is -4 and y is -1. So y is -1, x is -4, and there we go. Clean up your square. -4 plus 1 is -3. Squared is +9 times a is 9a. Okay, so all I did was clean that up. -4 plus 1 is -3. Squared is +9 times a is 9a. Subtract your 3 so we can solve for a. We get -4 equals 9a. Divide by 9 and we get that a is -4/9. And a lot of times it's not going to be very pretty. Our equation is the same as the top with your A filled in. Y equals, A was -4/9. The rest of the equation, x plus 1 squared plus 3. So again, quadratic and absolute value are pretty much exactly the same when you graph them or when you write their equations. We're going to hold off on exponential and move to this very last page we have. I'm sorry, they won't be this way all the time, but remember we had to add in what we had from yesterday, okay? We're going to hold off on exponential. I'm not going to do this last problem. And all we're going to do is look at these and tell me what happened. So we're just describing them. I'm not asking you to graph them. I'm not asking you to do anything. I want you to tell me what happened. So if we look at this, what I do graph is the vertex. So what would be the vertex of f of x? Remember, we change x and keep y. So change the x and keep the n. So for f of x, the vertex is change x to +3, keep the y or the n. So it just wants you to know how we moved from one to the other, and this is how we're going to get there, okay? Your g of x vertex, change x, so -2, keep the end 3. So here's what I'm going to do now. Graph them. 3, -4, and -2, 3. How did we get from f of x to g of x? It's asking what directions did we go and how much. So remember, we're going from f of x to g of x. So it's just like rise over run. 1, 2, 3, 4, 5, 6, 7. Up. 1, 2, 3, 4, 5. Left. 5 left. You can also do this by the coordinates. You don't have to graph it. I do not graph it ever. Okay, so the graphs are pointless to me when I do it. Here's what I think about. I think about a number line. This is your x. Remember, x goes left to right. This is your y. It goes up or down. Okay. So 3 to -2 on the x-axis. Which way does that go? 3 to -2. If I'm looking on a number line on the x-axis and I start at +3, which way do I go to get to -2? Left, right? Is everybody good? Left, correct? So that would be your left. And then how many units is it between 3 and -2 on a number line? That's where that comes from. You don't have to graph it on the paper, but it kind of helps sometimes. Same thing here, from -4 to +3 on the y-axis. From -4 to +3, I would be going up, and they are 7 units apart. I don't care which way you do it. I showed you both, okay? So I'm not going to graph the other ones. You can if you want to. I'm going to start with my f of x vertex. We're going to change x, keep y. So change x, keep y. Same thing on the next one, change x, keep y. So change x to +5, keep y to -1. Remember, this is your x and this is your y. On my x-axis, if I go from -2 to 5, what direction am I going in? Right? And then how many units apart is -2 and 5? 7. You're going to talk, you're just going to do hands in. Okay. Same thing on the other one, from 3 to -1. On the y-axis, on +3 to -1, I would be going down. And 3 to -1 is 4 units apart. That's all it's asking you is what is the translation? How did it move? Again, I don't need you to graph it, but if you'd like to, you surely can, okay? On the next one, change x, keep y. So -2, -4. This is the last one that we're going to do because the other one is exactly the same. Change x, keep y. So 1 and +3. Ignore that I even put that on there. This is your X and your Y. To get from -2 to 1 on the X-axis, from -2 to 1 on the X-axis, I would be going to the right. And they are 3 units apart. On your Y-axis, from -4 to +3, I would be going up, and they are 7 units apart. And that is it. That's all we're going to do, okay? So I'm going to stop sharing and stop